Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture number 7 for the course of Microprocessor Theory and Interfacing. My name is Engineer Jaffar Ali and I am instructor for this course. So let's start with the recapitulation of the previous lecture actually. In the last 6 lectures, we have discussed about starting from the introduction to microprocessor towards its evolution. Then we followed their different kinds of microprocessors 8085A and 8086, and also we discussed some things about 8088 actually. And after that we discussed about different instructions sets of 8086, specifically that how you can use different kind of instruction lines, or you can say codes, for different kind of processing while using a 8086 microprocessor. And after that we discuss about some kind of thing that is known as addressing. We learned about 4 to 5 kinds of addressing out of about 12 addressing modes. Keeping that pattern in mind, today's our topic will be about assembly language programming. So what's assembly language and how it is used while using the instruction set for the 8086 microprocessor, and which tools do we need and which softwares do we will have to use for this kind of programming. We will discuss that in today's lecture inshallah. So let's start today's lecture. Today's lecture is about assembly language programming and its tools. So first is, what is assembly? So you know that there are several kinds of programming, but the very common and the very low level basically is assembly language programming. I've already given you assignment of LLP and HLP, high level program and low level programming. So this is the first kind of LLP, basically assembly language programming. Let's see what this assembly language is all about. It's about the programmer view of a computer system. This is for the user actually, or the programmer that is going to write the instruction set for given specific of task. And the tools will be that we will be discuss inshallah today will be ALP tools, and how you can represent data, different kind of data in certain instruction languages, in instruction sets actually. That will be discussed in today's lecture. So some important questions that inshallah you will learn about after this lecture is basically, what is assembly language, why do we need to learn this assembly language, and what is machine language, and how is assembly language is related to that machine language. After that we will look at what is assembler and how is assembly is related to this HLL or HLP. And is assembly language portable, means you can change this language, and we have already discussed that several points of this today's lecture in the previous classes as well. So stay tuned and let's discuss. So these are basically is the programming hierarchy of different kind of languages that you can use. So the first one is basically application programs. You know that there are several programs that you can use for developing an application. So that programming is basically known as application programming. The second one is basically HLL or HLP. This is known as high level languages or high level programming. So that kind of programming in which you use high level languages, these are basically known as high language programmers. Similarly, after that we will discuss about this ALP, that is assembly language program, and you see that this is basically a low level language, and you can say also it can be termed intermediate kind of thing. It can either be a user point of view, or it can either be the server point of view. So we will discuss about the programmer or the user point of view in the course. So after that there is a machine language that how this ALP program is basically turned into machine language, basically for the microcontroller to understand, or microprocessor to understand. So this block is basically showing you a microprocessor or microcontroller or microcomputer, and to specify your demands towards this microprocessor, you have to write a assembly language program, and this assembly level program will be changed into machine level programming, and that machine level program will be shifted towards or move towards this microprocessor. So you see that there are different kinds of steps. Basically, either you can go from here and the machine will convert this thing into this pattern. Or if you want to go with ALP, this HLP, so you will go from here in the downward direction like this. But this is the most low level languages. You see that this is the user friendliest in terms of user friendliness. This is the very low level languages. This is not that much user friendly, but it is mostly in a difficult language to write in the instruction set. And the most difficult language is basically a machine language. A user cannot write different programs. It is possible to write in this machine language, but it is not highly recommended or used because of its difficultness. So that is why we are going from this assembly language programming towards this microcontroller or microprocessor controlling. So assembly language and machine language, you know that a native basically machine language is a native to a processor. It is not native to the user actually. It is some kind of language which is built only for the sake of the processor. A user will have to face very much difficulty while understanding or writing programming in machine language, because it is not that much user friendly, because it is native to the processor, not the user. So it is executed directly by the hardware. So this instruction set mostly comprised of ones and zeros. So imagine a code. If you are given a code about in terms of 1010, so you will not be able to understand that what does this thing means. So you see that this is a most difficult programming because it is using the codes of ones and zeros instead of the other codes like move or anything that we have already discussed. That was basically assembly language or mnemonics, you can say. So assembly language is slightly higher level language as compared to this machine level language, but it is already in terms of low level languages. So that is why you can see that it is kind of intermediate kind of language in terms of the user friendliness. So its readability of instructions is much better than machine language. So you already know that if you have given the code like this and if you have given the code like this, you will be much easy. It will be much easier for you to understand this code instead of this code. So this code is not that much user friendly as compared to the assembly language programming, because it has more readability as compared to this one. Similarly, the other you can say the property or characteristic or of this ALP is basically it is one-to-one correspondence with the machine instructions. So each term or each instruction will be separated, dealt separated by this machine language program. Assemblers translate this assembly language to the machine code. So you need to have some kind of assemblers. So assemblers are those things that basically converts your assembly language into machine language. So in the diagram, you know that let me show you. Here you will need actually assembler in this, between this. So you will give your programming ALP programming to a assembler, and that assembler will be converting your commands or instruction set to the machine language one by one. So this is known as assemblers. And in the last, basically there are compilers that are used to translate high level languages into machine language codes, either directly or indirectly. So if you have a code like you are using a high level languages like Python or anything, most of the students are trying. I've given the assignment and most of the students have I must appreciate that they are going towards this high level programming like Python and Java, etc. And for that you will need to have some kind of thing that is known as basically compiler. So what does this compiler do? Compiler basically converts this your HLL directly into this machine language without involving this step. So compiler is a thing that basically converts your the high level programmings or coding into directly machine language instead of converting into the assembly language. So that is known as basically compiler, or it can be giving you the option to go directly or indirectly via assembler. So you have two options. Either you can use a high level programming and control this microprocessor unit or microcontroller unit either directly, that you are converting this without involving the assembly language, or you can go indirectly, and you can involve this assembly language programming as well. So if you are given with the, you don't have the facility of a compiler, and so you also can take the help from this assembly language programming and the assembler. So if you are using something without involving a compiler, you will have to follow this route from going towards microprocessor from the high level programming. So this is basically a generic overview. So you can see that if you want to go from higher level languages towards the machine language level languages, you can either go from the compiler, or you can use the compiler to shift your language into assembly language, and after that code is converted into assembly language, you can use assembler to convert into machine language. So it is basically a two step, you can say indirectly. This is the indirect path, this is the indirect path. And this is your direct path. Now here comes a kind of question that if you can have direct path, why do we need indirect path? So this question is basically your bonus question, and I will answer that. If anyone don't answer in the class, I will give you the answer, and then you will have to ask me this question, that why do we need a direct compiler, indirect compiler, this route, if you have given this opportunity also. So there are several scenarios where you have the ability to go from this level to this machine level languages, but you do not have you do not want to follow this route, you want to follow this route. So there is a basically scenario situation, and I will discuss that situations and scenarios with you in the class, inshallah. You just have to answer me, or you can ask me. So let's go with some examples. So let's say this is basically English. You want to assign D as the sum of A and B plus 10, A times B plus 10. So this is basically the code for the HL programming, and you can see that this is very much easier to understand, that D is equal to A times B plus 10. So this is basically your higher level programming or higher level languages. And a statement in a high level programming is translated typically into several machine language instructions. So you see that HLL provides you a better opportunity to control this thing. In HLL you can write a single instruction set. You see that this is a single instruction set if you are using HLL, but if you are compelled to use assembly language programming, you have to do 4 instructions. You can see that you have to move your accumulator into some kind of register, and after that you have to multiply it by B, see that, and after that you have to add 10 into it, and after that you have to move the total result into D. So this is basically ALP, assembly language programming, and you see that this is a 4-line instruction set. But high level languages provides you the formality or the compatibleness while using 4 lines into 1 lines. So in HLL you can go only in 1 line for this kind of instruction, that this is assigned to you. And in assembly level programming this is much difficult, because it involves much instruction codes or sets instead of single line. So let's see that how the assembly language is different from the machine languages. You see that this is very much difficult to remember. These codes are very much difficult to remember. So you are using the same thing, you are doing the same thing that is discussed over here and here, but instead of doing it higher level language or assembly level languages, you are doing it machine languages. So machine languages are that thing that is not user friendly, they are native to processor. So this is basically for your processor will have the ability to understand these things very much conveniently as compared to this and this. But this is from user perspective as compared to as respect to the user friendliness, and this is the thing that basically machine have the ability to understand more easily. So what are the advantages of this higher level programming? So you know that it is much more easier, much more faster, much more friendly, user friendly. So you can have if you want to increase some codes, or if you want to do something more, it is very easy to upgrade or update your code in terms of the higher level programming. But if you are using a code like ALP, that this thing, it will be much difficult for you, because you see that in let's say if I ask you to just convert this multiply into let's say plus, so you just have to change a sign in HLL, while in ALP you have to convert this whole code actually. You see that instead of this you will have to change this line as well. So the whole code will be have to focused and corrected as their needs. So programs are portable. Let's talk about the portability issue. A higher level languages provides you the a kind of a scenario or assistance that programs, these programs can be shifted to one IDE. This is basically IDE, the integrated development tools. This is known as IDE. So if you are writing a Python code, let's say Python is higher level programming or higher level codes, languages. So if you are using a Python code, and you are using one kind of software, it is very much uh, um, easy to convert your this code or shift your this code from one tool to another tool. You can use another tool, another software actually, to run the same code of Python. It will provide the same result. But this is not the case as we talked about ALP. ALP is not portable, but high level programmings are usually portable. You can use as much as tools you want, and you will not have the problem or issues while converting your programs or shifting your softwares or tools. And assembly language programs are not portable. If you are writing or you have written down complete programming for a specific microprocessor, you won't be able to use that code for another microprocessor. You will have to regenerate or rephrase your code as need of the other microprocessor. So ALP is not portable, user portable, or you can say portable. You cannot convert this or you cannot shift either this tool into another tool. So let's moving further. Why do we need to learn this assembly language programming if you are given the option of using the higher level programming, which are much more faster and easier to use? So why do one want to learn about this assembly language programming? So you have some reasons that this assembly language programs are also mainly focused in terms of your education. There are mainly two reasons. The first one is the accessibility to the system hardware. As you are going near to, you can see that as you are going down, you can see that as you are going towards this microprocessor, you are actually having much difficulty, and the much difficulty means that you are actually using a different programming tool. So if you learn this different programming tools, you can easily learn these codes as well. So this is just a practice for your future. So the first thing is that you are from here you can assess this microprocessor more quickly as compared to from this point of view. So you are near to this microprocessor, and the more near you get, the more difficult scenarios you will face, and the more scenarios you solve while using these lines or these codes, you will be able to learn these higher level codes very much quickly as compared to this course, because you are founding your base very much strong as compared to this scenarios. So you will have the opportunity to learn this other languages very quickly. This was the first reason. And the second reason is basically space and time efficiency. So you see, this is not the first thing that comes into mind, but if you are able to write a code of ALP or assembly language programming, let's say in one day, so in future you will be able to write a high level programming for the same code in, let's say, 1 hour. So it will give you a higher time efficiency as compared to this ALP in future. So understanding, you will be able to understand different source of program that cause your program to work in efficiently. You will have the ability to tune the program performance, and you will make your writing compact code. You will be able to write a short code while in the future you are using this high level coding or high level programming. So this is your basically base, and the more strong your base is, the more higher and the more stronger building you can build upon it. So there are some kind of applications that are discussed over here while discussing assembly level languages as compared to the higher level languages. So you can see that the first type of application that use this kind of language is basically business application software, or writing a single platform or medium that is too large size. So you can have two options, either to go with the HLL or assembly language. So the HLL provides you the formal structures and make it easy to the organization or the user, and for its maintenance as well as in the scenarios of large section of code. But in this provides you a minimum formal structure, so no one so one must be imposed by the programmers who have the varying levels of experience. So here this will be difficult to control a business application, and this programming will be much easier when you're talking about the business application point of view. Similarly, if you are using some kind of application that is basically hardware driver, so this is much simple as compared to this codes. Let me tell you how. So I will also give you an example. So this language may not provide the direct hardware access, this HLL, while this assembly language provides you direct access towards the this thing. Actually, let me show you how. So let me go into my settings. So let's see, this is my USB ports, and let me just go to the quickly towards this thing, and if you go to the properties, you get the details of the driver immediately. Let me show you. Here's the, so you see that these are the codes, and this is not high level programming. This is basically this assembly levels or other lower level programs. So this is basically, you also have the different kinds of things, and you will find that these are not that much user friendly because it is using some kind of assembly level codes. So you see that these are the things that are mostly used in terms of hardware device drivers. Similarly, if you are using to write a program that is for business application for multiple platforms, this was for single platform, and this is kind of application that can use multiple platform. Let's say you are using an application that is used in iOS, in Apple's, and Androids as well. So you can see that these are the programs that are using different platforms or different operating systems or different tools. So this programming are much more, you can say Java is much more recommended, but if you use this AL programming, that is a semi-language program, you must be recorded separately for each platform. You will have to write a same code for this thing, and you will have to write different code from this platform. So if you change the platform, you will have not the thing, or you get your opportunity to write the same program and use it in different platforms. So you see that this is not recommended if you are developing some business application tools that are used in the different platforms on different operating systems. Similarly, if you are using some kind of embedded system and computer programs requiring direct hardware access, so you see that if you know that this requires direct hardware access, this is ideal, because this executable code is very small and it runs very quickly. And you can also use this thing, but this is not that much efficient. If you develop such a kind of coding in future, do let me know, and do mention me in the credits as well. I will highly appreciate if you develop your own stuff like this. But currently there are things, there are codes, but they are not that much efficient because of this hardware access. So this ALP provides you direct access. I have already discussed you, because it is, you can see, near to the processor or hardware, so it will have the direct access towards this coding. So that is why it is mostly used in the ALP if you are using embedded system and computer games that require direct addressing. So let's talk about a programmer view of point, or you can say programmers a view of a computer system. So there are several languages. You see that there are several languages from where you can start. You can either start from the higher level languages, or you can start from the assembly level language, or you can go from the operating system. There are several things that uh, you can follow, but one cannot be uh, expert in all of these. This is basically increased level of abstraction. The higher you go, the higher user friendliness you get, but at the cost of something that each level hides the details of the level below it. So if you are going in the most easy way, that is this high level programming, you will not be able to understand these things. These will be hidden to you. Similarly, if you start from this scenario, all the things below it will be much difficult to you to understand in the future, and you will be able to learn these things as quickly as possible. So the very basic is digital logic. That is why you learn the subject DLD and gates from the very beginning of your science subjects. You learned about the gates, logic gates actually, and or etc. And in the before your matriculation, and the reason was that this is the smallest or the lowest level. If you have the expertise of these gates, you can easily go to this level, and if you get the expertise of this micro architecture, you can easily get to this section. I have started this course from this set, you also know that, and from this I have jumped to this set. And after this semester, in the next semester inshallah, you will be able to jump at this level by yourself. So these are different kind of levels that you will be learning, and you have learned during your educational career. So let's see about the programmers view in very much detail. There are application programs, and you know that application programs or high level programs such as Java, C++, Pascal, Visual Basic, .NET, WordPress, you name it guys, Python. These are basically all the application programs, and you can develop certain applications while using this higher level programming. So these are some kind of languages, and you need some kind of programs, compilers and assemblers, and we have discussed that. What is that? The next thing is ALP or assembly level language program. So you will have this level. This is at level 4, and you are using basically mnemonics, which I have already explained to you in the previous classes, that what are mnemonics, how they are used. We have discussed about two classes actually in this instruction set of specifically for this assembly level programming. So now I hope that this won't be that much difficult to you, and it has the one-to-one correspondence to the machine language, and it can call the functions written in the operating system level language. It can program the programs written in the ALP are translated into machine level languages, and already we have discussed that in the previous slides actually. The third one is operating system. This is much more difficult. The lower you get, the much difficulty level increases. It provides the services from the level 4 and level 5 programs. It can be translated into machine level languages while using the different kinds of compiler or assemblers. The next thing is basically instruction set architecture, and we have already discussed this is used specified for a processor. You will see that this is specified how a processor functions. If you change the processor, maybe the instruction set slightly change, and this is basically comes into the machine instructions, and their registers and memory are exposed. You can easily convert or shift your data from a register to a specific memory, or from a specific memory towards a register, or an input output port as well. The second last is basically the level 1, that is basically microarchitecture, and these are very much close to this digital logic circuits, and these are things that you actually use in the labs that trainers provide you. This is kind of trainers, that is microarchitecture, and using a control execution of instruction, machine instruction, you can easily control any LED or small devices. The last thing, and that is very much difficult as compared to the programming. So you've already learned about that. If you want to learn programming, the main thing that you need is basically logics. So you have to follow the logics. And how can you one can be expert of any language. If you have the ability to create a logic, you will be able to understand this, and you will then jump into this level, and further you can jump above this. So the main thing that need to be learned very much early, that is basically digital logic and the logic gates, and how they are implemented using transistors. This is basically TTL, transistor logic. I hope that you have learned these things in the previous semesters of DLD courses and any other courses that uses logic gates. So the next thing or the last thing that we need to discuss in this lecture is basically what are the tools and how these tools are required to use kind of assembly level programming. So the first thing that you need is basically assembler, and you know that assembler is a program that basically convert your source code. Now what is source code? I will tell you. Source code into the object files. So there are two things. One is source code and the other one is object file. Source code is that thing that you write. Let's say you have written a code. So this is basically your source code that you are providing to the assembler, and assembler converts this into a machine understandable code, and that code is basically known as object files. So machine creates some object files. So if you do not have a clear idea, let me tell you how this thing works. So I recommend you to download a game that is known as PUBG or any other game. So you will see that in your mobile device you will find a folder that basically is known as files, and in your files manager or files you can go to the folder of Android, and Android, in that folder you will find a further subfolder that is basically named as OBB or OBJ in mostly different devices. There are some devices in which there are OBB and there are some is OBJ. And if you go into that folder OBB or OBJ, you will find a very much heavy file that is basically your object file. That object file is basically the code that is given to your mobile phone, as it is machine level language. So you have assemblers built in your different kind of programming codes devices and other digital devices that converts your source code and convert it into the object file, and using that object file your game is basically compelled to run on your mobile phone device. So this is the important file from which you can access your game, not this file that you downloaded or you made. So if you are making your own game, let's say you name a game, you produce or build a game and you name it after my name, let's say Jaffar Ali, and you are that much able to write a source code. So the main thing that you will need to have this code running onto your device as a game should be this object file. You have something that converts the source code into object files, and that thing is basically nothing but the assembler. So there are several popular assemblers that are developed or emerged during the last years of the family specifically the family of Intel microprocessors, and this includes TSM or NASM or GNU. This is the mostly used processor assembler actually, this thing, and you will use this also in your labs as well, inshallah. I'm not sure, but I hope that you will be able to use this MASM, that is micro assembler from Microsoft. So this is these are certain types of assemblers that are mostly famous in your this kind of topics. Now there are some things known as linker and link libraries. So if you are developing a code or you have written a code that is source code and you convert that source code into some object files, you will have to need the need to link that object files to different kind of libraries. So it is not possible to run a single program from a single object files. So how do we combine these different files, the supporting files, with this object file? So these are the things, basically this is known as a link library and linker. You need a linker program to produce your executable files, and this executable files is basically exe files. Exe files. This program will be this kind of files will help you to run the program, not the object files. Object files will, along with the supporting files, will the link libraries. These are the things, and these are mixed together using a linker, and this will create a executable file. You know that what is a executable file? .exe type file. This is application file. So this, after clicking this device, you will be able to run your program. This is not sufficient. This alone is not sufficient. This alone is not sufficient, and if you mix them using a linker, you produce executable program, and that program is basically there to run on your device. So you see that link32.c is the linker program that provided with the MASM distribution for linking 32-bit programs. You will also use a link library for an input and output. There are several libraries. You can not limited to one. You are not limited to use a single library. You can use multiple libraries. The more libraries you access, the more difficulty a program becomes, and the more difficult it is to handle. So you know that a PUBG is more difficult to run as compared to a normal game. Let's say if you are using a simple game that is using only one library file, so it is much lighter as compared to this heavy games. I'm just giving you, I'm not a fond of this games actually, but I am the fond of the backend of that, how these things work. So that is why I'm going to tell you, I'm not recommending you to play these games. I'm just asking you to look into these things, so that you can able to understand the things behind these things, the major or the basic things that are behind these major breakthroughs. Most of my students play this game. That is why I am going to make them understand using their languages. That is why I'm using this kind of examples. Furthermore, there are some different libraries. You can use these different libraries, and you can use different consoles under Microsoft Windows. So let me show you how you can use this tool. This is very much easier tool, and you can use whatever you want in this kind of tool, in this tool, according to this kind of scenario in which you can access all of your folders. Let me show you. I can access every folder into my this thing. So this thing is basically containing such directories, and if I want to go to a certain directory, I can also go to that as well. Let me see. I want to go into the let's say the saved games. So I can use this save games. So I'm now entered into the save games, and there are 3 more directories in the Microsoft games, and if I want to go further into that Microsoft, I can go to that, and let me show you what is inside that. There are only some folders that inside this games folder. So these are several tools that you can use with your own under the operating system of Microsoft Windows. So let's talk about debugger. So debugger is a kind of tool that provides you or allows you to trace the execution of a program, that how the program is actually executed. So you can have the access to go one by one. If you have given a code and you want to see let's say this is your code, and you want to see what is going on with every line of code. What does this code do? What does this line do? What does this line do separately? So you can have a debugger, and debugger will allow you to look at these instructions line by line, or one by one, or code by code, or register by register. You will have the opportunity to look at the registers and the different memories, that how they are going to upgrade. And for that you will need, if you are using a 32-bit window, you can use a debugger of 32-bit. There are several types of debugger. If you are using a tool that is basically compatible with 64-bit of computer yours, so in that case you will need a debugger of 64-bit. So you will need that that thing in mind also, that your debugger should be compatible to your Windows mode. I have given the example of 32-bit because in the previous slides I talked about 32-bit. You can see that there are 32-bit. If this is basically 64, so I just have to make the debugger compatible with my 64-bit Windows. Now what is editor? Editor is a kind of tool, or you can say a window in which you can edit your program. So this is a kind of editor looks like, and there are several editors different softwares of coding use different editors, but mostly they have same options like save, open, delete, cut, paste, search, evaluate, call, junction, or jump. These are the several tools that you will be looking at while you are using any editor. So this editor allows you to create assembly level programming source files. You can create source file from here. You can see that this is your source file, and this will be converted to something like this. You see that something like, not like this, something like this. You see that, into machine level languages, and for that you need assembler. So that's all for today. I hope you have learned a lot. And if you have any questions regarding today's lecture, you are most welcome to ask that into a class. And I'm sorry for the delay of this uploading, because there is electricity issue in my area, and I wasn't able to record my this lecture yesterday. So that's why I'm uploading it one day before. And you know that mostly I upload 2 days before the lecture, but there was electricity issue, and that is why I wasn't able to upload it yesterday. So tomorrow's lecture, I hope that you watch this video at least once before coming to the class, because the more you ask, the more you learn. That's all for today. I'll see you in the class. Thank you. Allah Hafiz.